On page 163 in the textbook, if you have it, there is a workplace skill problem. I really like these problems in the margins because they relate to real life. They're problems that we can encounter on the job. So if you don't have the textbook, let me read a story to you. And this is the picture set that goes with the story. Sometimes you will need to compare similar data in different formats. A manufacturing company has collected the data shown in the graph and table that describes the relationship between time in hours, that's the independent variable, and the number of items each factory produces. That's the dependent variable. The number of items depends on the number of hours they run. How does the slope of a line showing this relationship for factory 1 compare to the slope of a line showing this relationship for factory 2? So the first question we need to ask is, how do the slopes compare? And I'm going to add the next question in just a minute. Let's go ahead and answer this one, and then we'll worry about the next question. Okay, so first of all, this is the table that I was given, except I've added 2 rows up here because I want to remind you that the independent variable is the x and the dependent variable is the y. And the same is true on this graph. So that would be one thing that I would want to compare. Are the variables in the right places on both graphs? Now, I could graph the table, or I could make a table for the graph. Either way, it doesn't matter. But that's a lot of extra work if I know how to find slope. So I'm going to start with my graph. Now this one, I can simply count the slope. I can say, first of all, I need to figure out the scale. In other words, what does one box represent? On the bottom here, each bar, each line represents a half. Let me just do it this way. So you're talking about 0 hours. Here's half an hour or 30 minutes, 1 hour, 1.5, 2, 2.5, 3, 3.5, 4, and so on. So the bottom, the hours are scaled in half hours. The items are scaled. Every 2 boxes represents 500 items. So we're counting by 500s, but we're skipping 2 boxes each time. Okay, so let's do some counting on our graph. We're going to take rise 500, run. Well, let's not use that one. Let's use the actual point. So we rise 1,000 and we run 3. You rise 1, 2, 3, 4. That represents 1,000. So rise 4. So you can see the stair steps starting to build. If you're counting actual boxes, it's 4 to 3. If you're counting actual numbers, it's 1,000 to 1.5. In other words, this point is at 1.5 and 1,000. This point is at 3, 2,000. So that's the pattern on the stair step. So the next one, if I wanted to predict the next stopping point, I would rise 1,000, which is the equivalent of 4 spaces, and I would run 3. Cool. I didn't realize that would do that. I just discovered something that will be very helpful to me soon. Okay, so there would be the next point if I were predicting the next stopping point of this graph. So this one would be, and I'll put it in red because it's a prediction, at 4.5, up, here's 2,000, this would be 2,500, and then this would be 3,000, and that would be the next point. So if you wanted to predict the next stair step, you could do that just by graphing it. You see that nice stair step slope. It's pretty steep. The slope's pretty significant. But let's figure out what it actually is. Now, I'm not going to use the slope formula. I'm just going to count boxes. So it's 4 boxes up and 3 boxes across. So the slope for this graph, simply by counting, is 4/3. Rise over run. So let's highlight that, because now we need to find, we found the slope for our graph. We're halfway there. And we're living on a prayer. No, we're not. We're halfway there. But we have to find the slope of our table. Guys, I'm silly. I've had way too much sugar and way too much coffee. All right, on the table, I can't just count boxes, so I'm going to have to use 2 points and find the slope. So the first point I'm going to use is 1/1500. And the second point is 3/4500. You youngsters won't even know the reference to that song, Halfway There and Living on a Prayer. So here's x1, y1, x2, y2, and I'm going to apply my slope formula. And just to remind you what it is, I know you're tired of writing it, but the more you write it, the better you'll remember it. Y2 is 4,500. Y1 is 1,500. X2 is 3, and X1 is 1. So we're left with 3,000 over 2, right? Yes. And that is the same as 1,500 over 1. Now, I want to call your attention to something. You're going to hate me here. Remember, this is rise, and this is run, which is the same as saying this is y, and this is x. So y is 1,500, and x is 1. Look at this. What did I just say? Y is 1,500, and x is 1. I like that. That just confirms that that point and that slope are the same amount. That's a good thing. So, where does this leave us? We're supposed to compare the slopes. Are the slopes the same? Are the slopes the same? Well, what do you think? Is a slope of 1,500 to 1 the same as a slope of 4 to 3? Would 1,500 to 1 simplify to 4 to 3? It's a good question. here's something that I would like to know. Since I have this nice graph, let's make a good use of it. What happens on this graph when x equals 1? So at 1 hour, let's guesstimate where we are on this graph. At 1 hour, we're past 500, but we're not to 10,000, to 1,000. So we're not even to 750. We're at about right there. What is that? Maybe 700, 675, somewhere in there. I'm going to estimate about 675. Now on the other data set, at 1 hour, 1,500 items had been made. So let's put this in actual terms. The slope is steeper on which graph? If you put this one in terms to compare it to 1, you would have rise over run. So in 1 hour, this group is making 675 items. This group is making 1,500 items in 1 hour. So no, the slopes are not equal. They're not even close. The first factory is way outproducing the second factory. It's taking this second factory to get to 1,500. It takes them 2.5 hours. So when we say that to compare the slopes are not equal. Okay? And I think I'm going to take the time to go ahead and do something here. I had thought I wouldn't do this, but I think it might be beneficial. I'm going to graph that table that we have. All right, so let me bring in this graph, and let me just try to copy this table. Yes. All right, so the independent variable, that is the which axis? The x. Is going to be hours. And we have 1 hour. It doesn't give us a value for 2, but it does for 3, and it does for 4. So technically, we don't know 2. That's okay. And then the vertical axis, the y, is also your dependent variable. So the number of items produced depends on the number of hours worked. And we have 0, 1,500. I'm going to skip that spot and then go, actually I'm not going to skip that spot. Let's just keep putting in, this would be 3,000. Then 4,500, this is scaled by 1,500. And then finally 6,000. So at 1 hour, this company's producing 1,500. Now it could be because they have more workers, or they may have better workers. We don't know about 2, but we know that 3 is at 4,500. And we know that 4 is at 6,000. Okay. Now here's where you have to be careful. When you look at these two graphs, you think, man, those look like they're about the same thing. They're doing about the same progress. But what you have to realize is that the numbers are different. The scale is different. This graph starts at 500. This graph starts at 1500. So you can't just rely on what the graphs look like. You actually have to do the math. Now, we can estimate the production here at 2 hours. So here's what it's telling me. In 1 hour, they produce 1,500 items. In 2 hours, they could produce about 3,000. In 3 hours, they could produce 4,500. In 4 hours, they could produce 6,000. And I'm very glad actually that I drew this, because looking at those two, they're pretty similar. But the numbers are not the same. The hours are, but the y-axis is different for the two graphs. So you have to be very, very careful. And that's why the slope is different. For the slope to be the same, the y-axis has to be the same in both situations. So if they're not the same, you can't rely on the slope being the same. Now, if it's proportionate, that's not necessarily true. But that's a good rule of thumb. You have to really pay attention not only to the line, but to the numbers that make the line. All right. It says, first of all, how do the slopes compare? Slopes are not, that factory 1 is outproducing factory 2. Which factory will produce the most items in an 8-hour workday? Well, that's going to be factory 1, because their slope is higher. They're producing faster. And how do you know that? It's because they're double the production of factory 2. This is a very good exercise to think through. It's not easy, but it's a good one to think through.